Hi, everybody. So this was a question that a lot of people had on homework. I think it was 2G, number 48. Basically, it says a football is kicked straight up into the air. It hits the ground 5.2 seconds later. And that's it. That's all the information that they give you. And it seems like, oh no, I can't do this. But there's a lot of hidden assumptions here and some things we can take advantage of that we'll use. Part A says, what was the greatest height reached by the ball? Assume it was kicked from ground level. So that's what I got here in my diagram. Here's my football player, and here's my ball at different moments in time. So the ball is going to get kicked up, and then it's going to come back down. All right. And so a couple things that I can do. This is kind of similar to what you also did in your Airball 2 lab, right? Is I could draw my initial velocity vector, and let's see, greatest height reached by the ball. So let's say then here's going to be my initial moment right after the ball is kicked. Here's my final moment, and that is when the ball is at its maximum height. So at its maximum height, I can draw like a height vector. Or I'll just say it's a displacement vector, right? Because it started here and then is going to end up where the final moment is. And then I also know that my final velocity at the peak, this is what's a nice thing to make it at the peak, is I know the final velocity is 0. And then I can do a VOVAT. So my initial velocity, I don't know. They didn't tell me. My final velocity is 0. My acceleration, it's a free fall problem. It's up in the air, and so its acceleration is going to be negative 10 meters per second squared. Displacement, that's what I'm looking for. And then time, I do know, well, I almost want to say 5.2 seconds, right? Because that's what was given to me. But I need to be careful. They're saying that the football player kicks it up into the air, and then it hits the ground 5.2 seconds later. So that means that from here to here was a total time of 5.2 seconds. Now, this isn't always true, but it is true in this scenario that actually, if I assume that it starts on the ground, that it hits the ground, and that I assume that it was kicked from ground level, then it started right where it ended. And basically the time then that it takes to go up would be the same time that it takes to go down. So if it took 5.2 total seconds to go up and down, then that must mean that time to go from, so if I called this, let's call this A, and we'll call this B, right? The time to go, so TAB, the time to go from A to B, let's make that a different color. Well, that's going to be half of the total time. So the total time is 5.2. So that is what? 2.6? Yep. So TAB is 2.6 seconds. So this is 2.6 seconds. All right. Well, now I'm going to try and solve this. Let's see. What am I looking for? I'm looking for the displacement. Well, I don't know my initial velocity, so that ain't going to help me. Let's see where this takes me. So V equals V naught plus AT. So let's use this to find my initial velocity. Once I have my initial velocity, then I can plug it in for... I can plug it in using my beta equation. So let's try this. Let's go with So I know let's isolate V naught first. So I'm going to say V minus AT over. Oh, no, that's it. That's going to be V naught. So my initial velocity is 0. Boop. Bye. See you later. And then my acceleration is negative 10 times the time, which is 2.6. So that gives me an initial velocity of 26 meters per second. All right. And then, so now I'm going to use the beta equation. That's d equals v naught t plus 1/2 at squared. And now I know my initial velocity. So I'm just solving for the displacement. So it's 26 times 2.6 plus 1/2 times -10, and then 2.6 squared. So that's going to be 2.6 squared times -5 plus 26 times 2.6. I'm getting 33.8. So I hope that's right. If not, yell at me. Okay, and then it says, what speed did it leave the kicker's foot? Oh, I already calculated that. It's 26 meters per second. Haha. Did part B even without noticing it. So there's that. There's part A. All right, bye.